Hi, Timothy Unkert here, and what I'm going to do in this program is use Python to find the roots of a cubic. And to do that, I need to know a little bit about finding the roots of the cubic and the rational root theorem. So before we start with our Python program, I'm going to open up a draw island, which drawisland.com is just a website where you can draw stuff. I'm not affiliated with them in any way, but I just like to use it to demonstrate. So let me show you what I'm talking about. So a cubic typically is formed when you multiply three binomials together. It doesn't always have to be, but you could have just like an x or something like that. But anyways, I'm going to do it with three binomials here. So let's have x plus 2 times 2x plus 1 times x minus 3. And let's say we have this cubic and we want to figure out when the cubic value is equal to 0. So where the roots are is where the cubic is equal to 0. So I'm going to set this equal to 0. But in our program today, we're not going to have it in this factored form. We're going to have it in the form where this is all multiplied together, so more of a standard form type thing, and we have to figure out the roots. And we're going to do that using Python. So what I want to do is I'm going to multiply these together. But to figure out the roots, to figure these out, we use the zero product property. We'd set x plus 2 equal to 0, 2x plus 1 equal to 0, and x minus 3 equals 0, and solve for the three different values of x. They would be x equals 3, x equals negative 1/2, and x equals negative 2. Now, if any one of these equals 0, well, you have this quantity. Let's say this quantity is 0. Well, then it's 0 times whatever this is, times whatever this is, so it would have to be 0. Likewise, if this was 0, we'd multiply it by these first two, and we'd get 0. And if the middle one was 0, we'd multiply it by these other two and still get 0. That's how we find the roots, okay? But typically, you won't be given it in factored form. So let's multiply it out first. So I'm going to do this x plus 2 times 2x plus 1 first. So x times 2x is 2x squared. X times 1 is plus x. 2 times 2x is going to be 4x. And then 2 times 1 is 2. And we're going to multiply by x minus 3. And this will equal 0, of course, still. Okay, so I do 2x squared times x is 2x cubed. X times x is x squared. Four x times x is 4x squared. Two times x is 2x. Now I have to multiply all these by negative 3. So negative 3 times 2x squared is negative 6x squared. Negative 3 times x is minus 3x. Negative 3 times 4x is minus 12x. And negative 3 times 2 is negative 6. And that's going to equal 0. Okay, so now what I want to do is combine my like terms. I have nothing like 2x cubed, so I'm going to write that out front. And then I'll cross it off as I go. That helps me keep track. Then I'm going to add x squared plus 4x squared plus a negative 6x squared. So that's going to give me negative x squared. cross all the x squareds out. Okay. Next, I'm going to take the terms with x. So negative 3x plus negative 12x is negative 15x. Oh, but I forgot. When I multiply these out, this should be 2x. So let me erase that, fix that. So we should have 2x plus negative 12x plus negative 3x. That'll give us negative 13x. Okay. Cross that, and that out. And then we have this minus 6 at the end. And this whole thing is equal to 0. Okay, so typically we'd start with a form like this, and we have to figure out what the roots of this cubic are. And to do so, what we need to do is the rational root theorem, where I would take all the factors of negative 6, so that's going to be plus or minus 1, 2, 3, and 6, and divide them by all the factors of 2, which are going to be plus or minus 1 and 2, because you could have negative 1 times negative 2 would be positive 2. So if I divide these out, that should give me the roots. So again, we said, figuring it out from factored form, we see that the roots are x equals 3, x equals negative 1/2, and x equals negative 2. Okay, so if I do 6 divided by positive 2, I get positive 3, which is this one. If I do, let's say, negative 2 divided by positive 1, or positive 2 divided by negative 1, I would get this root. And if I did positive 1 divided by negative 2, or negative 1 divided by positive 2, I would get this root. Okay. So once we come up with these potential solutions in our program, what we're going to have to do is put them back into this original cubic. And if we put them back in and this side equals 0, we know we have a root. Okay. Typically, when you do this, though, you'd use synthetic division, but this is another way to do it. You don't have to use synthetic division by this method, although synthetic division does work. But with this method, we figure out the potentials and we plug them back in, and we see when this side equals 0, and that should give us the roots. Okay. So now I'm going to pull up a text editor, and we're going to, I'll pull up my terminal, and we're going to create a program, and let's call this, I'm going to open it with Vim. So I'm just going to say Vim, and then rational root dash YT for YouTube, and .py. That will make it a Python program, the .py at the end. Okay. And something with my vimrc I have to fix. Anyway, so we want to first create a function to find the possible solutions. Okay, so let's call this function, and define a function in Python. I type DEF. So I'm going to type DEF possible solutions, and then we're going to take in. We need to take in A and D. Okay. Because we're taking all the factors of D, dividing by all the factors of A to find all of our potential solutions. Okay, what we do need to create is an array. And so I'm going to have an empty array at the beginning. So I'm going to say potential, or no, let's just call it possible solution array. And we're going to define that as an empty array. And now we're going to have to append stuff, and that means push it into that array. So what I'm going to do is I'm going to do a for loop in Python. So I'm going to say for x in range, and I'm going to define my range starting at 1 and going up to D, but D plus 1. And actually, before we do that, we're we're not going to do a possible solution array just yet. We want to do a factors of D array, and that's going to be empty. And we're also going to have a factors of A array, okay? All right, so anyways, so now back to our for loop. I have to put D plus 1 because it will go up to only the number before the number you put in the range. It's going to start at 1. So I'm going to loop through, and I'm going to do an if statement. I'm going to say if, I don't need a, if D modulo x, if that is equal to 0, that means that D is divisible by x. That means that x is a factor of D, okay? In that case, what we're going to do is we're going to take the factors of D array, and we're going to append x, okay? We're going to do the same thing now for the A value. So we're going to say for y in range, we'll start at 1. You don't want to start with 0, so you want to define it as 1 because you don't want division by 0. And we'll go up to A plus 1 because it only does the number before in Python. We'll say if A modulo x, if that equals 0, then we're going to take this factors of A array and append y, okay? And since we're using y, I want to do A modulo y. Okay. Now for our possible solution array. Okay, so we're going to go for factor D in factors of D array. What we're going to do is now do another for loop for factor A in factors of A array. We're going to take the possible solution array and append now factor D divided by factor A, okay? And at the end of this function, we are going to return the possible solution array, okay? So that's our function for finding the possible solutions. All right, so I'm going to go up here and fold a little bit of this. I didn't fold quite what I wanted. Let's fold it a bit more. It's not letting me. All right, we'll fold the top part. Anyways, all right, so now I'm going to create a function which is going to be, we'll define it by df, and we'll say roots of cubic. We'll call the function roots of cubic. We're going to take in A, B, C, D, and we also want another variable. We want let's just call this pos solutions. That's going to equal the possible solutions function when I pass in A and D. Okay, and I'm going to take that pos solutions and pass it into this function. Okay, so we now need to actually set a value for the cubic. So I'm going to say, well, first I'm going to do a for loop. I'm going to say for possible solution in pos solutions. what we're going to do is we're going to say cubic value is equal to, we're going to do A times the power of pos solution cubed plus B times the power of pos solution squared plus, let's go down and do another line here, plus C times possible, C times possible solution or pos solution plus D. Okay. And before I forget, I want to make sure that I import math. Okay. All right. So now what I'm going to say is if, and actually we're going to need an array. So let's go up here and we'll go and create a solution array and make an empty array. Okay. Get rid of this white space here. So we're going to say if cubic value, if that equals 0, well, then that means that that potential solution is an actual solution. So what I'm going to do is I'm going to take the solution array and append the possible solution. Okay. And then at the end here, I'm going to return the solution array. Okay. So that's going to be my function for that. All right. I went for a bike ride this morning. I'm trying to get my sugars back in me. Okay, so those are our two functions. I'm going to move this line down here. And okay, so we're going to say pos solutions equals possible solutions A and D, and then then we'll say the solutions equals roots of cubic when you pass in A, B, C, D, and the possible solutions. Okay. And then we're going to say for the solution in the solutions, what I'm going to do is I'm going to print the solution. And actually, let's make sure it's a string. So we'll print the solution plus just a space and a new line. And then actually before that, I also want to print something like x equals, and then plus here. And okay, and then before I do that, what I want to do up here is I want to print the solutions of the cubic are, and then just do that and make sure we go in a new line. Okay, so that's what I've got so far. All right. So what I'm going to do is now we're going to take a look at what A, B, C, and D are. So in this case, A is the number in front of x cubed. So A is 2. B is the number in front of x squared. So that's -1, even though they don't write the 1. C is the number in front of x. So that's -13. And D is the number by itself. So that is -6. Okay, so 2, -1. So we'll go up here and we'll define A is 2, B is -1, 1, C is negative 13, and D is negative 6. Okay, let's open up a new window here in my terminal. And let's just run with Python 3. We'll do rational roots dash yt.py. What's the name of this file? Rational root. Okay. Now let's run it. The solutions of the cubic are blank. That means there are no solutions. Okay, so let's take a look at what's going on. Take a look at my notes here. Oh, one thing we did forget, if we go up here, and we forgot also that, well, D is a negative number, A is a positive number. So we're not going to run the loop here. So what I have to do here is I'm going to have to convert these to absolute values. So I'm going to say ABS A, because if it's negative. Now A is positive, but D is not. So that may be part of our issue. So we want to have a positive. But then the other thing that I didn't do is we have to loop through the negative values as well. Remember, because I said back here, over here, that we have plus or minus. So we have to loop through the negative values as well and push them into the array. So I'm going to have to say this again, actually, and let me just be a little bit more efficient. Let me go down here, copy all this, yank it, as they say in Vim speech, and then just all I'm going to do here is have a -1 times this in front. Okay. And so, this is part of the debugging process. Sometimes you do stuff and you're like, why isn't it working? Okay. So go here and let's try this again. And we see now that we've got the solutions of the cubic are x equals 3, x equals 3 again, because it loops through and it'll divide 6 by 2, and it'll also divide -6 by -2, and it'll get 3 twice. Okay. Now I could add something to the program to eliminate a solution that's the same, but for right now, this is a good way to be able to create a nice little program that will allow you to plug in your values that you want. Now, we could also in this program, we could just go over here. We could get a little bit interesting with this and take in inputs as well. Okay, so so what we could do is we could use inputs. We could say that A equals let's just say input, what is the value of A, okay, and then we do that for B, C, and D, okay, and we could do that up here as well. Okay, and then let's go back to our terminal here and let's run it. What is the value of A? I'm going to say 2. What is the value of B? -1. What is the value of C? It was -13. What is the value of D? -6. And we got an error. Okay. So we have to convert these to integers. So what I'm going to do is run a little macro here. I'm going to do QW0. Then to the first occurrence of I, insert mode, put a parentheses in, go over one, delete that one, JJ to go back to normal mode, capital A to go to the end, JJ to back to normal mode, a J to go down, end the macro 3 at W, and we didn't want inputs. Sorry, wrap that. I'm a little tired. Okay, let's actually not do that. All right, so let me just show you what I want. I want input and then integer. Okay, so actually I'm going to run another macro. QW0, 1 at F, the parentheses, delete letter, then 0, 1FT, 1FT, and then insert, put a parentheses here, and we'll say int. No, I want the integer in front. Integer in front. Okay. And I think that'll be good. And escape. And then go down to the next line, end the macro. Let's see if this works. I kind of messed that one up. No, it didn't. Let me just do this manually. Sorry, I'm trying to get all fancy here. And what am I doing? I am tired from the bike ride today. Integer input. Okay, that should be good. Go back to the beginning here. Okay. Go back. And all right. Now let's try our program. Clear this out. What is the value of A? 2. What is the value of B? -1. What is the value of C? -13. What is the value of D? -6. Okay, and then it takes in the value. So you could do that also for your program. But if I enter something that doesn't have a solution, we probably want to continue and do something with that. So we'd have to do something with the array. But that's going to be a little bit beyond the scope of this video. This is just writing a Python program to solve and to find the roots of a cubic when you know values that will work, okay? So maybe in a later video, I'll go ahead and we'll do some exceptions, like if they put in something besides an integer, like if they put in the letter A, we'd have to have a try and except value. But in this case, we're just doing it just to kind of go through and show you how the math works and how it will work in a Python program running through and the logic behind it. I hope you liked this video. If you did like this video, please like and subscribe and hit the bell for notifications, as it will really help the channel grow and continue to motivate me to make videos like this. If you have liked and subscribed, I thank you, and I hope to see you continuing to watch my videos and enjoying them in the future. Have a great day.